All right, today we're going to dive into a pretty wild idea, one that connects two of the most mind-bending fields imaginable, quantum mechanics and artificial intelligence. We're going to explore a really precise structural link between how a quantum system gives you an answer and how a large language model creates meaning. It sounds completely out there, I know, but you'll see that the geometry underneath it all is, well, it's shockingly solid. So let's just jump right in with the core claim.
And there it is. This is the bold statement that this whole explainer is built around. Notice the language here. Frank Schmidt isn't saying it's like it or it's a nice metaphor. He's saying it is structurally the same. That single claim, that incredible assertion, sets the stage for everything we're about to unpack.
So our job here is to really put that claim to the test. Does this strange analogy actually hold up when you look closely? Or is it just a cool idea that falls apart under pressure? Let's find out.
So right off the bat, the parallels start to line up. Okay, they're both vectors, they both exist in these insanely high-dimensional spaces, but the real meat of it is that both of them represent a moment of certainty, a clear answer you get when you perform a specific action, and crucially, that one answer doesn't define the entire reality. They are answers, not the whole world of possible answers.
To really get this, we've got to break it down. So let's start with the quantum half of the equation. We need to understand what an eigenstate really is, not in some sci-fi way, but just in terms of its pure geometric function.
Okay, the most important word here is invariance. An eigenstate is simply a state that when you ask it a very specific question, in physics we call that applying an operator, it doesn't change its direction. It's stable. Think of it like a compass needle. You can turn the compass casing all you want, but that needle is stubbornly going to point north. That stability, that unchanging direction, is the answer to the question, which way is north?
But, and this is a huge but, that certainty isn't some universal truth. It is completely conditional. It's only certain relative to the question you just asked. If you ask a different, incompatible kind of question, that certainty just vanishes. It's the classic quantum trade-off. If you ask for a particle's exact position and get a perfectly certain answer, its momentum becomes completely unknown, and vice versa.
This really clarifies it. An eigenstate isn't the thing itself, it's a relationship. It's not the whole reality, it's just one direction in one particular coordinate system or basis. It gives you this one little point of local certainty, but it leaves the vast, infinite space of other possibilities totally unresolved.
Okay, got that? An eigenstate is a stable answer to a specific question. Now let's pivot and look at the other side of our analogy, the AI embedding. And you're going to see an almost identical structure pop up.
Just like an eigenstate isn't a thing, a word's embedding isn't some fixed dictionary definition stored in a file. No, it's a position. It's a location on a massive, complex map of meaning. And that location only gets its significance from all the other locations around it. And this is key from the context you give it with your prompt.
And here we go again, the same pattern. An embedding isn't a final truth about a word, it's a potential for meaning. And that potential only crystallizes, it only becomes certain inside the specific context of a prompt. The exact same vector for the word bank can mean a riverbank or a financial institution, depending entirely on the question you ask. It's the same underlying structure.
And this is where it gets really interesting. This is where the analogy stops being just a cool comparison and starts to tell us something profound about how both of these systems actually work. It's all about how they generate specific, concrete answers while keeping a whole universe of other possibilities alive. And boom, here it is, the structural bridge, laid out right next to each other. You've got the quantum system on the left, the LLM on the right. Both start with a giant space of possibility, a Hilbert space or an embedding space. Both need an interaction, a measurement or a prompt. And that interaction doesn't destroy the space, it just projects the system into a stable, coherent answer, an eigenstate, an embedding.
This is the secret sauce. Just let that sink in. Local certainty, global ambiguity. Both systems are designed to give you a sharp, clear, local answer right now, in this moment, while keeping the global space of everything that could have been said or could have been measured completely intact. And that ambiguity isn't a bug. It's the whole point. So in the end, neither an eigenstate nor an embedding is a final truth. They're more like conditional commitments, a temporary alignment. They give you a stable answer for right now, for this context. And that stability only lasts until the next interaction comes along, whether that's another quantum measurement that's incompatible with the first one, or just the very next word the AI generates in its response.
Now, if this structural parallel holds, it has some really deep implications for how we think about meaning itself. It suggests that meaning isn't something we just look up. It's something we have to actively create through interaction.
I mean, we usually think of ambiguity or uncertainty as a problem, right? Something we need to get rid of, a bug in the system. But what if that's totally backwards? What if ambiguity is actually the engine?
Well, check this out. A system that's globally precise, where every concept means exactly one thing, would actually be useless. It's just a giant lookup table, a dictionary. It could never generalize or understand an analogy or be creative. The real power, the magic, comes from this controlled ambiguity, the fact that the system preserves uncertainty, that it's always ready to be reinterpreted in a new light.
And this quote just hits the nail on the head. Meaning is not stored. It is elicited. It's not a static file you retrieve. It's a dynamic response that has to be pulled out, to be coaxed into existence by the act of asking, by providing a context.
Think about it. A quantum measurement doesn't just reveal a property that was sitting there waiting to be seen. It forces the system to cohere, to collapse into an answer. And a prompt doesn't find a pre-written answer in the LLM. It elicits a coherent continuation out of that vast space of possibility. In both cases, it's an active creation, not just discovery.
So where does all this leave us? Well, this analogy does more than just connect two cool fields. It actually gives us a totally new geometric way to think about what knowledge and intelligence even are.
So, we can boil down the shared blueprint to these 4 properties. Both systems are locally fixed, they give you a clear answer, but they are globally incomplete. The wider space of possibility is still there. The answers are totally relative to the operator, to the question being asked, and the whole structure is evolution preserving. It allows the system to change and adapt without getting stuck. This is the shared DNA.
And this leads to a pretty radical reframing of what it means to understand something. What if understanding isn't about how many facts you have stored in your brain? What if instead it's about your ability to navigate this high-dimensional space, the ability to find stable, coherent answers to all sorts of different questions from different points of view without the whole system just falling apart?
This is the big takeaway. It's a shift from thinking about intelligence as a database full of information to thinking about it as a kind of geometry. It's about the shape of the space, the ability to find stable points within it, and the agility to move between them. And so we'll end with this final, really provocative thought. Maybe the truest measure of intelligence, whether it's in a quantum system, an AI, or even us, isn't what it knows in any single context. Maybe it's about how gracefully it can move between different, even conflicting ways of seeing the world. A question that really makes you think, and one that doesn't just belong to physics or AI anymore.